Hello students, welcome to Sourav sir's classes. The question is the imaginary parts of the eigenvalues of the matrix P is equal to 3 2 5, 2 minus 3 6 and 0 0 minus 3 are. So now to calculate the eigenvalues we need to do P minus lambda I and we need to equate this to be equal to 0. So P minus lambda is equal to 3 minus lambda 2 5, 2 minus 3 minus lambda 6 and 0 0 minus 3 minus lambda is equal to 0. Now when you solve this you will get lambda to be equal to 1 minus 13 and minus 3. Therefore, the imaginary parts of the eigenvalues are 0, 0 and 0. So the correct option is option A. The next question is, let UV be matrices such that U is equal to 1 2 3 5 transpose and V is equal to 5 3 2 1 transpose. So U is equal to now 1 2 3 5 transpose. So the transpose of row vector is a column vector. So 1 2 3 5, this is U, and V is similarly 5 3 2 1. Then the equation U V transpose X is equal to V has option A infinitely many solutions, option B no solution, option C exactly one solution, and option D exactly two solutions. So where X is equal to x1, x2, x3 and x4. So UVTX is equal to V is equal to 1 2 3 5 5 3 2 1 x1 x2 x3 x4 is equal to 5 3 2 1. Now on multiplying this you get 5 3 2 1 and this becomes 10 6 4 2 15 9 6 3 and 25 15 10 5. x1 x2 x3 x4 is equal to 5 3 2 1. So that is 5x1 plus 3x2 plus 2x3 plus x4, 10x1 plus 6x2 plus 4x3 plus 2x4 and 15x1 plus 9x2 plus 6x3 plus 3x4, 25x1 plus 15x2 plus 10x3 plus 5x4 is equal to 5 3 2 1. Now let the first row be y. So we get y is equal to 5. Now if we analyze, the second row is 2y. So 2y is equal to 3. Similarly the third row is 3y. So 3y is equal to 2. And the fourth row is 5y. So 5y is equal to 1. Now this is not possible. So then the equation has no solution. That is option B.